A car is traveling on a circular racetrack with a radius of 250 meters. At a certain point, the car angular velocity is 3 radian per second, and angular acceleration is angular acceleration. Where will I write it? I'll write it this way: 1.5 radian per second. Second square, sorry. Determine the following: the car's linear acceleration at that instant. At what instant? Okay, wait. What instant? Car angular is so. Oh, sorry. Linear acceleration. Okay, at that instant, as when we start off. In which direction does the linear acceleration point? Okay, why is the angular acceleration? We have to figure out everything. Okay. The first thing is your linear acceleration has two components, right? We have to figure out the tangential acceleration, and we have to look into centripetal acceleration. Now, first thing is we look at tangential acceleration, capital T, small t. I confuse myself. Okay, it is given by r into alpha. That's one of the ways of finding it. This is 250 into, this would be 1.5, sorry. So that is your, right, alpha is over here, r is your radius. That's your alpha. So this is around 3 by 2, 125, 125, 250, 375. So many meter per second square, right? And then you have your AC, which is equal to r into omega square, or v square by r, whatever. But yeah, it doesn't work over here. This is 250 into omega is how much? 3. So this is 3 square, by the way, sorry. 2500, so 200, 2250 meter per second square. And now your linear thing will be, since they are mutually perpendicular, so we have, I'll write it as square itself, much easier to deal with it. AC square plus AT square, and this calculation you should be doing it. So this is 2250 square plus 3750 square. So solve it, the unit will be meter per second, and done. So this is all of this is your question A. Now your question B. In which direction does the linear acceleration point towards? It's quite simple. So this is nothing but your tan of theta, AT by AC, right? So this is pointing inward, your AC, and your AT, just a second, dot tangential to this. So this is more or that? Okay, that is more. This has to be small. So that will be your AT, this is your AC, and the resultant is pointing towards this. So you're measuring with respect to, 1 minute. This is your theta, right? Here is your theta, and that's your A. So opposite is your AT, and this is AC. And this would be how much, guys? 375 by 2250. And yeah, I'm just looking at the number as if I'm going to solve it. So this is theta is equal to tan inverse of some result that you guys can find it. Leave it to you guys. Okay, so this is your answer. This is with respect to AC. Okay, so let's mention that. Measured from AC.